Okay, so 7.0 was kind of a lot of information in one, and it just was the main thing that you need to know from 7.0 is that there are 3 different forms that we can write quadratics in. But this one on 7.1, we're going to focus specifically on vertex form because I think personally vertex form is super helpful and it's the easiest, okay? So back to basics. Quadratic. The most basic quadratic is the function f of x equals x squared or y equals x squared, okay? That's without any extra fluff, and it's the graph that has these exact points. These points you need to know, okay? Because this is our starting point every time that we do the lesson, anything from the lesson today, okay? If we are to graph those, we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay, and it makes our U parabola shape. Okay, that is the most basic quadratic that you could possibly make. Okay, but we can add a lot of extra things to get every other type of quadratic. Okay, and so we're going to study that and look at that closely. The first thing we're going to do is we are going to look at what happens when we put a number in front. Okay, when we put a number in front, if we look down, it says A. We put this A in front, okay? That A is a vertical stretch or shrink, meaning that it's going to take our graph and it's going to stretch it up and down, okay? Or it's going to squish it. And basically, you know whether it's stretched, okay? If A is big, meaning that it's a number that's bigger than 1, it's going to make it tall and skinny. So if A is greater than 1, it's going to make it tall and skinny. If A is between 0 and 1, then the graph will become short and wide. We're going to squish it, okay? So here's the cool thing. I'm going to show you what we do. If we have an A value, we are going to multiply the Y values by A. We're going to change the points. So in this example, let's say that we are going to have Y equals 3x squared. Okay, if we go from the original and we take the original points, which were -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and we are going to multiply the Y values by 3 because that's what A is. We multiply by 3. We get 4 times 3 is 12, 1 times 3 is 3, 0 times 3 is 0, 1 is 3, 4 is 12. The new graph would include the points -2, 12, so all the like up here, -1, 3, 0, 0, 1, 3, and 2, 12, which is up here. That means we've stretched it. I guess that point's kind of off. Ignore that point. That has taken our graph and made it really tall and really wide. So we can transform the points instead of taking the graph and going, oh, I'm going to make it 3 times as big. Okay? The next thing, what if we add a number out to the side? So if we add a number out to the side, that's our K. Okay, and the K value, if we look at our notes down here, it says K is a vertical shift. K moves the graph up or down. It moves in the direction of the sign, meaning if it says plus K, then it moves up, and vice versa, meaning if it says minus K, then it moves down. So let's do Y equals x squared minus 4. Okay, what we would do is we are going to take the Y values, okay, and we are going to move them all down. So we're going to add or subtract from the Y's. Okay, so we're going to subtract 4 because this says to move down 4. So if we look at my original points, I'm going to write them right here because I'm kind of tight on space. It's -2, -1, 0, 1, 2, and then it's 4, 1, 0, 1, 4. I'm going to subtract 4 from each of my points. So 4 minus 4 is 0, 1 minus 4 is negative 3, 0 minus 4 is negative 4, 1 minus 4 is negative 3, and 4 minus 4 is 0. So my new points, first one is negative 2, negative 2, 0. Okay, that's that point. The next one is negative 1, negative 3. The next one is 0, negative 4, 1, negative 3, and 2, 0. So now, if we look at it compared to our original graph, it looks like we have moved everything down 4. So the k on the outside moves everything up and down. Okay? Then, the only other thing that we could add is we can add something inside. Okay? And so that's our h. And so h is our horizontal shift, meaning it moves the graph left or right. This one's a little bit different than k because it moves in the opposite direction of the sign, meaning if it says plus h, it moves negatively. So we're going to do the opposite to the points. But the other thing you need to realize is this, if it's moving left or right, changes your x values. Okay? So for example, if we do the example y equals x minus 2 squared, that means we're going to add 2 to my x's. Okay, so we're going to have the original points. We're going to have the original points that we have negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. Okay, and we're going to add 2. So if I add 2, I get 0, 1, 2, 3, 4. So I'm going to graph this, and my first point is at 0, 4. Then my next point is at 1, 1, 2, 0, 3, 1, and 4, 4. So this has taken my graph, the original parent function, and it has moved it over 4. Okay? So main thing you need to understand from this, you need to know what A, H, and K do. Okay? What their purpose is and how it changes the graph. Okay? I'm going to do this just so we have it. Remember, this moves it left or right. Okay? And we do the opposite to your x value. Okay? And here's kind of a cool thing. This is another way that some people look at it, is if we get the vertex, this is why we like vertex forming. We kind of talked about it in 7.0, but the vertex is h and k. H being how far we move it, left or right. And remember that k is up and down. And we can get what it is by moving left however many spaces. That's how we get h. And then k up and down. And remember, h is the opposite of the sign on the inside here. So this whole assignment is basically just graphing from vertex form and using transformations to do so. Hang in there. If you need help, set up a Google Meet with me, email me, and let's set up a time, and I'd love to answer your questions. Good luck, guys.